We did
Last thing we talked about?
acids.
Acids. Okay, let's see if you guys can name some acids for me. And not the stuff you drop.
Hey, you want to make a deal?
What's our deal?
If we do really good today on nomenclature, like super good, like knock it out of the park, then you'll postpone lab 7.
I'll cash app you $5.
See, the money always helps, you know, but still gonna say no.
Okay.
I am just trying to help you help yourself to an A. That's what I'm trying to do.
You just missed out on a profit.
I know. It wasn't $1 million, so you know, a couple of mil. Okay, so let's name these 2 acids.
That one is sulfuric acid, H2SO4.
Okay.
And H3P should be hydrophosphoric acid. Look at that.
Carry us out.
Dr. Henry's office.
I remember when I had a secretary.
We did that one in homework. That one is delirium. No.
Hydro. No, wait.
I heard somebody say something.
Hydrotelluric acid.
Hydrotelluric. Good job, Abiri.
Has no oxygen.
Let's go.
That one is di 8. Dichrome acid? I don't know 8, bro. Dichromic acid?
This would have the per in it for the name.
Dichromic acid.
There it is.
There we go.
Thank you.
Who was that?
Fabiana, probably.
I put the per in there.
It's team effort, Alex. We can take our test as a team too. Learn better off each other.
Hey, I'm actually doing that for my 1A class.
What in the world? Did you cash out
For 10 points on their exam.
We don't get no lifelines. Sink or swim.
You gotta, that's because you're people before you. They set the standard.
This one's a sulfur, isn't it? H.
Hydrothiocyanate acid.
Nope. No hydro in it.
No, it's a sulfide, isn't it? Sulfide carbonic or something.
He's close, but he put a hydro there.
Cyanic acid.
Thiocyanic acid.
Name it.
Piece of cake?
Mhm.
Did you sing?
Okay, so all we did was that if it's ATE, we dropped the ATE, because isn't this thiocyanate? So we dropped the ATE, we add IC, and acid. I ate organic apples, despite them being poisonous. Okay, question, concerns, Cash?
None of those work on you.
I know,
Professor, I have a question.
I have an
So-
answer.
Hopefully you do, because I took the practice test yesterday and I'm more lost now than I was before I took it. So
Okay,
when we're looking at like the polyatomic ions or whatever, sometimes like, let's say, I think it's iodine, and then you know how it changes, not their charge level, but the bottom number. How do we know which one goes first? Because like sometimes, I don't have a dang example with me, but sometimes I can't find it on the list, but I know it's one of those. How do I know whether it's I don't even know how to explain it. Never mind. I'll get back to you on that one. Let me find an example. That way I can better ask the question.
okay. That's fair. Okay, any other questions?
I have a question. So on some of them, you're putting hydro in front of them. And then on other ones, you're putting nothing in front of them.
Okay, so let's take a look at the ones that have hydro in front of them.
Is it just because they have no oxygen?
Because they have no oxygen. And this case is a special case because instead of an oxygen, we have a sulfur. And that sulfur accounts for that thio. So you're going to treat it as if it's kind of like an oxygen.
Sulfur counts as thio.
Yeah. So if it's in front, it's typically a thiocyanate. Cyanate.
Meaning 3. Thio.
Thio, not tri. Tri means 3. Thio means thio is so sulfur was called something else a long time ago. And when it was called that something else a long time ago, it started with the THIO. And so we use thio for that. So like if you look at the bottom of it, you have thiosulfate. That means you have an extra sulfur, right? Instead of an oxygen. So like sulfate is SO4, right?
Yeah.
2 minus. Thiosulfate is S2O4. I mean O3. S2O3. So this guy's called thiosulfate because you're replacing one of the oxygens with a sulfur instead. And so we put thiosulfate, right? Because as you see, sulfate is SO4. We're taking one of these oxygens and we're putting in an extra sulfur. So we call it thiosulfate.
Okay.
Just a special case. You have it in your polyatomic ion table.
So we don't ever have to worry about the hydrogen 2 in the front of these?
The hydrogens make it an acid. That's what causes it to be an acid. So the hydrogen 2, that means it's balancing out, is H plus. Each hydrogen is a plus, right? And this is only when you're in an aqueous solution, okay? When you're a solution and it's aqueous, that happens, okay? So even though we're talking about acids, so I didn't write around AQ behind it. So that always lets me know if there's an H in front of it and there's an AQ, it's aqueous, right? So that means that this is going to be an acid. That means that these H's are really H pluses that balance out the ionic charge.
So H2s are always dyes, right? Dihydrogen?
No. No.
No.
So again, do we call this guy dihydrogen?
Oh, no.
Okay. So H2, again, here when it's in water, it's going to be an H plus. It's an ion, the hydronium ion. The things that makes an acid is the hydronium ion, because the acid is called a proton donor. What is left in H plus?
What do you
Does it
mean?
have an electron?
Yes. No.
No, it doesn't have an electron because it's H plus. It lost its electron, right? Does it have a neutron?
No.
No. The only thing that it has is a proton. So acids are always called proton donors because they're providing an H plus.
So when there's an H2, it's basically not there since it's giving away the electron.
If there's this H2, like this H2 here, is just providing that positive charge to balance out the negative charge of that ion.
So that whenever we see that, we don't count in the H for the name. We just put like sulfuric acid.
That's right.
Oh, okay.
And then the only time that you count in H for the name is if there's no oxygen here. So this lets me know that there's no oxygen in this situation. It's a special case. So we call it hydrotelluric acid because there's no oxygen there.
So then those things that you taught us, like the I8 organic and the MyRide has or something like that, those are only for acids, right?
That is correct. That is only for acids. Sorry, I may be getting money. Okay, so are you guys clear on that?
Sure.
Yes.
Okay. Guys ready to move on to some harder stuff?
Yes.
You're supposed to nod, Kelsey.
Matt, don't lie.
Okay, so when we talk about covalently bonded compounds or covalent compounds, you're going to use those Greek prefixes that we were talking about with organic chemistry. So tri, di, mono. I may get this right one day. Mono meaning one, di meaning two, tri,
Meaning three.
three, tetra, four, penta, five, hexa, six, hepta, seven, octa, eight, nona, 9, and deca, 10, undeca, 11, dodeca, 12.
Dr. Henry?
Yep.
Before you go on, can I ask you a question really fast? Of the last 5 examples you gave us, I'm able to, I understand 4 of them. The H3P, it starts with hydro because there's no oxygen.
Mm-hmm.
And then we know it ends with acid because these are all acids. They start with H. And then obviously the phosphorus. But how would we know in that one if it's IC or OUS?
Because it's only going to be IC, right? Because there's no oxygen at all. Because remember, the OUS pertains to the oxygen. IC pertains to, if it's IC, let's see, hold on.
If there's IC, then there's an oxygen.
Yep.
So IC has oxygen and OUS is no oxygen.
No. No, if it's IC, it can have no oxygen. But if it's IC, it pertains to that 8, right?
Yes,
So,
ATE is IC
yes.
and ITE is OUS.
Exactly. So OUS, the IC, ITE, can't even think today. The ITE, what does that mean to you?
Doesn't that mean 3?
3 what? It doesn't necessarily mean 3. It just means
It loses 1, right?
It loses 1, right? 1 with what?
I don't know what the term of it is, but the little number on the bottom.
The subscript for what?
So like the PO3 on the bottom, it would be PO2, and then the charge would stay the same.
Okay, so this guy is actually phosphite, right?
Yeah.
Oh, okay. So that's
And this
on
guy is phosphate, ATE, right? So
That's subscript.
phosphate.
now what is the difference between the top and the bottom?
Subscript.
The subscript,
The subscript of what?
of the oxygen.
The phosphate has 4 atoms of oxygen, while the phosphate has 3.
And this guy is phosphide.
No oxygen.
Okay. Do you see the difference between them? What is the
Yes.
difference between the phosphide and the phosphite?
No.
The oxygen.
The oxygens, right? What is the difference between the phosphate and the phosphite?
The
The
oxygen.
number of,
Okay. The number of oxygens, right? They both have oxygens, but this one has 1 less. And then
Right.
hypophosphite has how many less?
1 less.
It has 1 less than the
Oxygen.
phosphite, right?
Right.
Because it's hypo, it's 1 less than the phosphite. Hypo means less than the phosphite. Right? Hypothermia, hypodermis, hypoglycemia, hypo. What does hypothermia mean?
Yes, I totally understand the hypo means less.
Okay, so that means that it's 1 less than the phosphite. So then what would be the? What would be the chemical equation?
PO2 for the subscript, -3.
PO2 minus 3, right? So now if this guy was forming an acid, we're going to balance out the charges with the number of hydrogens, right? How many hydrogens will I need to balance out those charges?
3.
3. So I would go H3, PO2. Okay, so now it has an ick. I mean, an like ITE. It has an IT at the end. IT. So since it has an IT at the end, what would I name this acid?
Okay.
What was that?
So it would be-
Be hypophosphorus acid.
Phosphoric acid.
Try-
Hypophosphorus acid, right? Hypophosphorus
Hypophosphorus.
acid. Okay, this guy has IDE. My ride has hydraulics. Hydraulics. IC, right?
Okay.
And that guy would be, you'd use whatever you have here, and you say, put a hydro in front of it. Do you see that?
Yes, I do. Hydro.
Okay, so again, the hint was my ride has hydraulics. IDE, I put hydro and IC at the end of it because there's no oxygens here. This is a phosphide, right? So if I look here, this guy is just a phosphide ion attached to 3 H pluses. That's all it is. It's just an ion.
Okay.
And,
Got it. Got it.
and you guys have to remember, acids are just a special case of an ion. Okay, that requires those H pluses instead of using sodium or whatever, you know. You got it? Okay, so.
Yes, Dr. Henry, I got it. Thank you.
Okay, good. So one of the best ways of remembering this is flashcards, right? Give yourself a couple of examples, and then you'll start thinking about, oh, and it'll start clicking, right? The more you see it, the more you do it, the more you do it, Kelsey, the more you do it, Kelsey, the more you do it, Kelsey, the more you're gonna get it, right?
Yes.
Okay, so let's move on to covalent compounds. Leave that one up there. Okay, so when you're naming covalent compounds, all you're going to do is the letter or the element that's up front, you give that its full name. So it's carbon, right? So this first one is carbon. The next letter, if it's at the end of it, you put an "ide" at the end. So "ide" serves two purposes. "Ide" can mean that it's a negatively charged ion, or it can mean it's at the end of the complex. Or in the case of ionic compounds, it's a negatively charged ion and it is the end of the complex. So we call this guy carbon. There's one oxygen, so we call it carbon monoxide.
Wait, you said I equals negatively charged ion and, or is it or?
Or. Oh, except when you're talking about ionic compounds. It's and in that case. Okay,
Okay.
So we call this guy carbon monoxide, or you could have called it monocarbon monoxide, but it's commonly called carbon monoxide. This guy is called what?
Carbon dioxide,
Dioxide.
because it has two.
This guy would be called
Nitric oxide. Nitrogen.
dinitrogen. Because you say for that first one, you got to give me the full name. So dinitrogen oxide.
So in this case, we wouldn't have to worry about, wouldn't have to be worrying about making sure that there is only one oxygen, so it wouldn't be mono at all.
You could say, you could call this dinitrogen monoxide. That's true. But you could call it dinitrogen oxide as well. So that mono is optional.
Okay, so if we put it, it would still be okay.
It would still be okay, yes.
Would this one be hydrogen dinitride? Oh, wait. Oh, you added an O at the end. I only wrote HN too.
Yes, so in this case, this is going to be dihydrogen. I mean, not dihydrogen. This will be hydrogen.
Hydrogen.
Dinitrogen oxide?
Dinitrogen
Dinitrogen.
Oxide? Only one O.
And these are called covalent compounds.
Okay.
So we don't have to worry about naming any of the others, like with the mono or the di or tri or anything like that. It would just be, I guess, the center one.
No, it all just depends on how many you have. So for instance, if I have
Hey, Doc, for the one you just did, why isn't it per in front of the hydrogen?
because this is not an acid and it is not an ionic compound. It is a covalent compound.
Oh, okay.
And one way that you can tell something is a covalent compound typically is if it's in its natural state is a gas. Okay, so this guy would be called
Tetraphosphorus.
Tetraphosphorus heptaoxide.
I'm gonna point with my little pick and go through this.
tetraphosphorus.
No oxide.
I could spell. Hepta
I like these ones better.
oxide.
So,
So actually, this
These
guy
are
would
way
be called
easier.
hept.
these ones are like
Oxide.
a lot easier compared to acids.
Yeah.
Then for the hydrogen one that you had just previously did, we wouldn't have to put mono in front of the hydrogen.
You could put mono. Remember, mono is optional. If you don't put it, it means one. If you just put hydrogen, it's just one hydrogen. So mono is an optional one.
It's preferred you only put mono for the last letter.
It is, well, it's not necessarily preferred. It's just certain things kind of passed on, like carbon monoxide, right? Although you could have called it carbon oxide, it would have worked out the same way. Or you could have called it monocarbon monoxide. That would have been fine too.
Already understood that there's only one.
So if you don't put a di, tri, tetra, that means there's only one. So if you just say carbon oxide, then that means there's only one.
Right. Yeah.
Okay. So let's do. Can I clear these? You guys got these down?
I do.
Yeah.
Okay. That G just means it's a gas and usually at its normal state. Okay, that's usually how we tell if something is going to be a ion. If it's AQ, then we know that it's going to be an ionic compound or an acid.
So this one would be hydrogen trichlor. How do you end chlorine? Or would it be like chloronic?
Chlorine, because you put the "ide" at the end for the last letter.
Oxide. Good job, Alex.
Yeah.
Ring, very nice.
Okay. What about this guy?
These are way easier.
Yeah, these are a lot easier. Is this the last thing you said you were going to teach us?
Nope.
Before? Oh,
I said this was the hard stuff.
this is the hard stuff?
Yeah, because all the other stuff is a piece of cake. I don't know what you guys talking about. You make it sound like it's really difficult or something.
The two flips.
This one, you thought it was D, but once I said it was a space note, you knew that one was C.
So pentahydrogen.
It's a pretty song too.
Go ahead, Cassie, go ahead.
Trioxide fluorine.
Fluoride.
Thanks.
Is it oxygen or oxide?
Right. Fluoride.
Really good word.
It's oxygen. Like,
Why is it not oxide?
Because it's not the end of the compound.
Oh, orange. Okay.
Telling you anything too, huh?
Trihydrogen chloride.
That's a 9. That's not an 8.
Like a whole other language. This is nona nitrogen. Undeca oxide. Right?
So with oxygen, oxygen is kind of weird. It will actually drop that A in all the cases, or it'll drop an O, and then it'll just put just the oxide. Okay. Tri is the only one that it'll keep. It'll say tri-oxygen. It'll keep that tri. So the I is the only one. And dioxide, it'll keep the I. If it's an A, it'll drop it.
No, but isn't 11 un?
Oxide or
Oh, you're right. It's un. You're right. My bad.
Yeah.
Un.
So it just picks and chooses which it always drops an I?
No, it always drops A's
why is it?
and
why
the
is it
O. So
why
if you look at it, remember when we did carbon monoxide?
Yes.
Did I put monoxide or did I put monoxide?
Mon.
Yeah,
So
because
why
it drops the O's and it drops the A's.
Why is it nona nitride or nitrogen? I mean, is that just for the ending when you drop it?
Yeah, so you use nona meaning 9, right?
Okay.
It just tells me how many nitrogens I have.
You got 9.
Well, no, I'm talking about how you drop the letter.
It's only for oxygen. Oxygen is the
Oh.
only one that you're going to drop the letter.
Oh, okay.
For testing purposes, since we're kind of new at this, will you still accept it if we wrote undeca oxide?
If you put an A in front of it, I'm
Yes.
going to dock you. I'll dock you a little points. I won't dock you a whole bunch of points.
Not
You
yet.
won't get completely wrong.
So it's only for oxygen that we drop the O and the A.
Yes.
That is correct.
Oxygen, drop O and A. I'm hungry.
So this is part of the reason why, remember when I told you inorganic versus organic, right? So these are inorganic nomenclatures. Even though you have carbon here, they're going to try to name it a little bit differently than what we would name it if it was organic chemistry. Okay.
So this one would not be octocarbon.
So you would actually, well, you would probably call it octocarbon.
Trihydrogen, heptaoxide.
That's right. Where organic chemistry, we would need that structure to kind of help us with that name, right?
What do you mean structure?
The structure, right? So octocarbon could be 8 carbons, right? And then we could have oxygens coming off of all of these, right?
Yeah.
Could we not? Or have oxygens going in between each of the carbons?
You could, but then wouldn't it be a propyl or whatever?
If it was,
Side chick or whatever? I mean,
what would that be? What family does that belong to?
I suck at these. Where you at, Beery?
Ether.
It's an ether, right? So that would be a special ether. So we'd have an O here, O here, O there, O there, O there, O there, right? So it really depends on the structure, okay? What it would be. And so this is a very generic way of naming it. It doesn't tell us anything about structure or anything like that. And it's a very generic way of naming it. Because you can't tell the structure from this name. I mean, can you?
No. You just know that there's
One
carbon,
that's on-
hydrogen, oxygen.
Are we we're dropping the A for hepta on oxide, correct?
That's right. So this guy would be, as you said, octa carbon is that 3? I forgot what I put. Yeah. Trihydrogen.
Heptoxide.
I thought we're taking out the A.
Thank you.
I would have docked you.
Yes, you would have. I would have got it wrong.
All for an A.
Okay. Questions, concerns, Cash?
No cash.
No cash.
Okay, so that's covalent compounds. And you want to make sure you're talking about the covalent compound and you're not talking about the acid. So if I gave you this, and I always put this on the test, always put this on the test. And I gave you this.
How are we supposed to know what you're... Oh,
Oh, aqueous.
yeah, aqueous.
AQ means ion and the G means covalent.
That's
Yeah.
right. So
Yeah.
what would we name this? What would it be? Name this guy here?
Which one? Oh, dihydrogen
Sulfur.
sulfur,
Yeah.
and then tetraox. No, tetroxide.
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 Because we can't have the A.
And then this guy.
Uric acid.
I'm gonna write the second line right here. Really?
Those flashcards, though.
Alright, so I'm gonna do
Go do your work.
our
You
lines
go
exact. Come on,
out,
closer,
children.
okay?
Piece of cake?
Yeah. This one, the compounds are easier.
Yeah.
What about this guy?
Hydrogen chlorine.
Hydrogen chloride.
Hydrogen chloride.
Chloride.
So it's important to look at the state of the
Yes.
compound. Okay.
Yeah. I always put something like this on the test. Always.
What we're doing right now.
Exactly.
Okay.
Mental note.
Hydro.
Hydrochloric acid?
Hydro.
Or no,
Hydrochloric acid. That's right.
Doing the phosphate like example kind of helps with that. It kind of helped a lot. The example you gave when Vanessa asked.
Yeah.
Yeah.
You said it helps with it, or it didn't help with it?
It did help.
Okay. Okay, so you guys, are you feeling it? Are you seeing it? And you see the distinction between the two?
Yeah.
Yeah, because they take this gas, they boil it into water. I mean, they bubble it into water, and that's how you get your acid. So once it gets into that water, it becomes that acid. Okay, so that is covalent compounds. Are you ready for your last one?
Yeah.
Last topic?
Let me make sure. Try to make sure I gave you the last topic. Yeah, I think it's the last one. I'll have to
Dr.
check my
Henry,
notes. Yes.
are we having a lab today?
That's right.
Kelsey, do you want to answer Eric?
Yes, Eric, you need to be in lab. He made lab 7 due Tuesday, so you need to be there.
Sorry.
Why are you apologizing? Don't apologize.
Oh, because I didn't even know. I just got here from work.
We're trying to
Okay.
to change the date, and he said no.
Eric, didn't you say you were going to give Dr. Henry money so we didn't have to do lab 7? That's what I heard.
I didn't say nothing.
That's what I heard too. I heard it was going to be $1 million.
Yeah.
If each one of us
Yeah.
gives him like $1,
If you each give me $1 million, that'll be perfect. You won't have to do lab ever again.
Let's just start a GoFundMe
GoFundMe.
for
Help
Dr. Henry.
some students out.
Okay, the last ones I want to talk about, they're called hydrates.
Hydrates.
Yes.
Hey, we can use these on our test, right? Our notes.
No,
Why?
because you need to know this. No, you can't use your notes on your test. You can use what I gave you, all these handouts and stuff. Yes.
So if
All
I
right.
type them up and print them out, it's like you gave them to us, right?
What was that?
And if I type them up and print them out, it's like you gave them to us, right?
No. But I'll make you a deal though. I'll give you guys a cheat sheet for the final.
All right.
What's on the cheat sheet?
I know.
Anything you want to. It could be back and front. Anything you want on it. But that's the only thing you get to use though.
All the questions?
But the final's cumulative, isn't it?
It is.
Oh, that's why.
Anything we want on the cheat sheet,
You can put anything you want on the cheat sheet.
including my phone.
Including what? Your clothes? You can put your clothes on anytime you want to put your clothes on it.
My phone.
Your phone. You can you get your phone on your cheat sheet on a piece of paper?
You could
Yeah,
just
keep it.
Just tape it in.
tape it to it.
No, you can't use your phone. You know better.
I actually did have a question.
Actually, you know what? I can give you a final that you can use your phone on. Sure.
No.
That'd be too hard. Stop.
Thought you loved us. Thought we were your favorite.
You are.
All right.
Okay.
We're
What was
ready.
the question that somebody had?
Well, I wanted to know if we were able
Honors.
to write like little stuff on the periodic table. Are we allowed to do that?
Like the
Like-
negatives, positives, yeah.
Yeah, that's fine. That's fine. I don't mind that.
Mhm.
But
Okay. Hydrates.
I hate these. I really don't like these.
Okay, so the way that we would go about naming this, you'd name this guy normally. How would you name this guy? What is the name for it?
Strontium? Strontium?
Strontium.
That you're gonna be practicing. I'm curious if you could memorize all of this.
Strontium what?
Two?
Strontium phosphate.
Phosphate.
Phosphate. Yep.
So why don't I put a 2 there?
We are gonna do.
Because there's an exception somewhere.
Heptahydrate.
Wait. Why don't I put a 2 there?
Because it's plus 2.
Because it's plus 2. It's in the group 2 metals. So group 2 metals, they're not transitional metals, so we don't use Roman numerals for transitional metals, right?
Yeah.
Okay. And then we put the Greek prefix, and then we put hydrate. Because when you drink water, you're what?
Hydrated.
You're hydrated, right? So we put set heptahydrate, meaning 7 waters.
We don't have to note that subscript anywhere.
I'm gonna emphasize the long.
The subscript balances out the charges. So no, you don't have to note the subscript anywhere at any point for nothing, right? Not for these. The only time you note subscripts for are for your covalently bonded stuff.
Long short means that when you do it 2 times, the first time you do it is longer.
Right. That is one of the biggest mistakes that a lot of students make is for ionic compounds. Ionic compounds, you don't note the subscript. Right?
And it's hard because there's so many things you're giving us at once and it kind of just all looks the same. That's the trouble I had doing your lab already. And
Well, the best way of doing it is by practice, right? Recognize, is it an ionic compound? That's the first thing you need to tell. Well, if it's an ionic compound, there's only 2 rules, right? Is it a metal and a non-metal? It's an ionic compound, right? So if it's a metal and a non-metal, it's an ionic compound. That means I have to sit there and balance the charges. Okay, so that's the first rule. We want to balance the charges. The next part is if it's an ionic compound, is it a transitional metal or is it a non-transitional metal? So if it's not a transitional metal, then I don't have to worry about it. I know what the charge is all the time. I don't have to worry about it. But if it's a transitional metal, I have to tell you what the charge is, right? Or you have to tell the whatever it is what the charge is. So I need to put the Roman numeral. Transition, meaning change. So that means it could be anything. So I want to make sure I let the reader know what it is. For non-covalent bonds, for covalent bonding things, I use prefixes. And then I put "ide" at the end. For hydrates, I name ionic compounds And if it says water at the end of it, then I put how many waters I have. So it's heptahydrate. 3 rules.
We're trying, Dr. Henry.
I'm gonna need to hear those 3 rules again so I could.
Could you do that again one more time?
I feel the same way though, Megan. I was telling Anna last night that I felt like overwhelmed. Like I feel like I really understand one concept and then the next day we do something else and I feel lost.
Well,
but
could
you're
you
right.
imagine doing this in the summer?
I know. You're right though, Dr. Henry. Practice.
Yeah.
Practice.
The way that you work through it is by practice. That's it.
Right.
If you don't practice every day, you lose it. Use it or lose it.
Right.
Sit on the toilet. Oh, answer nomenclature, right?
Hey, I dreamt about chemistry last night.
That's a good sign. That's a good sign. Okay. So let's get to the nitty gritty. So let's give you guys another shot at this. So what if I have,
Is there any exceptions in these hydrates that we should note?
I will give you one here in a second, I promise.
Why does chemistry always have to have like exceptions and special cases?
Ammonium phosphide
Thank you for giving this.
dihydrates.
Acid free.
I think we're okay. Thank you. Why don't you bring a chair on over?
Okay, let's see. One more? Or are you guys good?
No, do one more,
One more.
please.
Okay. And then I'll give you my exception. It's not really an exception, but it's something to remember.
Do you feel like nomenclature is the hardest that we're gonna learn in the class, or is there harder topics?
I kind of feel like nomenclature is part of the easiest thing because it's a lot of memorization, right? And a lot of students are really good at memorizing. I sucked at memorizing. So it took me a minute to kind of get the nomenclature down, but the way I did it is by flashcards. And once I got the flashcards, and then things start sticking.
Oh.
And then when you guys get towards the end of the semester, you'll be like, shit, why was I struggling with this? It made no sense. You know, you've done it so much, it becomes natural.
Smarties, your teachers have shown you the right way. I didn't get that on time.
Zinc sulfate pentahydrate.
Okay, Barry, let somebody else answer.
He's doing great.
Oh,
Mark.
oh, sorry. I want to fast forward it.
I can tell. Okay, Megan,
What's up?
give me a name.
I'm trying to look for that name on the periodic table. I can't find ZN, so gotta give me a minute.
Okay.
Dr. N, do you drop A? That's pen.
The first one would be zinc, and then SO4.
What was that, Rocky?
I was asking if I have to drop the A. Pen is penthydrate.
No, you keep the A. The only time you drop the A is with oxygen.
Okay.
Okay.
So I have zinc sulfate, pentahydrate.
So it's zinc sulfate. Pentahydrate.
Correct.
That is correct. Okay, so zinc is a transitional metal, but I told you that zinc was an exception, right?
Yes.
Okay, I just
So
want
if
to be
it-
sure that I told you. And
If
also,
if it had been like cobalt, Dr. Henry, we would have put cobalt parentheses Roman numeral 2.
that's correct.
Okay, got it.
Okay,
So zinc is the only exception?
zinc and silver. Silver is always going to be +1. If you just see silver chloride, it's +1. If they give you silver 3 chloride, that means it's +3.
Aluminum is +3, right?
Aluminum is always going to be +3. Okay,
We also got that emailed to us.
what email?
One of the tutors were nice and was telling us what the exceptions were.
Good.
That was Cole.
Yeah.
Okay, so are you guys feeling comfortable?
Somewhat, yes.
But you'll feel more comfortable after you do 300 problems.
I'm still mad at you.
Oh, you can be bad, that's okay. You can hate me. You can call me all the dirty words you want to call me. I'll let you guys go in rooms and call me those dirty words.
We're gonna get our own shirts.
That would be great. I would love to see that. Long as they're all uniform, but you should have them multiple colors though.
We should all do our group projects in them.
They're red shirts.
That would be great. Okay, so this is what we're gonna do, right? We got what, 30 minutes?
Yes, sir.
And you've guys gone over all the nomenclature. I want to go over one more thing. So if I have this guy, right? And I heat it up really hot and I get this guy. So what happens if you heat stuff up really hot and it has water in it?
Turns to gas.
So if I have salt and I boil out all the water, what am I going to have at the end?
The water will be gone. You'll just have salt.
I'll just have salt. So when we boil all the water out of here, this guy becomes zinc sulfate. But you want to let people know that you got rid of all of the water. So then we would say,
we boiled it.
zinc sulfate anhydrous.
And no more water.
No more water, yes. So it lets somebody know, because when you're doing experiments, there are certain experiments that you don't want to have water with. And you may be using this chemical and you want it to be anhydrous, that it doesn't have water, right? It's lacking water. So you want to make sure there isn't water. So if you have water, it could cause an explosion in some cases, right? So you want to let that person know that, hey, there used to be water in here. So I may have been an idiot and it may not have been totally done. So just be prepared.
So that word just means that there, no water.
No water. The water has been removed. That's what it means. So no water. No more water. Okay? So anhydrous means no water. Or
water has been removed.
Water's gone. Okay? Piece of cake?
Yes.
Okay. And I always put one question that deals with this on your test. So those are like, give me questions now. Okay, so this is what we're going to do.